Hello and welcome to the second part of our video on chemistry revision focusing on QA or qualitative analysis. Now in the previous video we did questions 1 to 5, so let us now take a look at questions 6 to 10. Okay, so number 6, a few drops of aqueous ammonia was added to an unknown solution. Now when we see aqueous ammonia, we usually know that this is a test for cation. Okay, and we would be looking for a precipitate. Now it says here a dirty green precipitate was formed, which is insoluble in excess aqueous ammonia. So we know that the ion present is Fe2 plus. Okay, after some time it was observed that the precipitate turned reddish brown. Okay, what is the cation? Okay, before that, reddish brown confirms that this is Fe3 plus. Okay, what is the cation present in the brown precipitate? So now we're looking for the cation in the brown precipitate, which we just mentioned is Fe3 plus. Okay, now this is actually an oxidation process. The Fe2 plus, which is a green precipitate, becomes oxidized to Fe3 plus as it loses an electron. So this Fe3 plus is a reddish brown precipitate. Okay, it is oxidized because it loses an electron. It has been oxidized. So just remember, oil rig, if you can remember, oil rig means oxidation is a loss of electrons, while reduction is a gain in electrons. So you can see here that the iron 2 plus has lost an electron to form iron 3 plus, therefore it has been oxidized. Okay, so you need to be able to remember the color of the precipitates. In the previous question, in the previous video, you saw that the blue precipitate indicated the presence of copper 2 plus. Okay, so let us now take a look at question number 7. Which of the following solutions can be used to distinguish between aqueous sodium hydroxide and aqueous ammonia? So we are looking for something to be able to distinguish between sodium hydroxide and aqueous ammonia. So we've got 4 different substances here that we can possibly choose. So the simplest way to look at this problem is to draw a table. If we have aqueous sodium hydroxide and we have aqueous ammonia here. Okay, so now let us draw a table and see what are the different things that we can observe if we added all the different materials. So 1, aqueous copper 2 sulfate. So if we added aqueous copper 2 sulfate, we know that there is a Cu2 plus. Okay, we will get blue precipitate here. Okay, but it will be insoluble in excess. And in aqueous ammonia, we will get a blue precipitate, but this blue precipitate will be soluble, or it will dissolve in excess. Okay, to give a deep blue solution. Okay, so we can actually differentiate between sodium hydroxide and aqueous ammonia if we use copper 2 sulfate, because we get different observations in sodium hydroxide and aqueous ammonia respectively. Okay, so let's see whether there's anything else. So let's see, 1 is okay. Let's see if we can use iron 2 nitrate. Now iron 2 nitrate has the Fe2 plus ion, and if you remember, for Fe2 plus ion, the reactions or observations will be the same for sodium hydroxide and aqueous ammonia, which is we get a green precipitate, and the precipitate will be insoluble, okay, in both excess sodium hydroxide and aqueous ammonia, which means since we're getting exactly the same reaction, we will not be able to differentiate between sodium hydroxide and aqueous ammonia using iron 2 nitrate. Okay, so this will be out. Let's see if we use potassium iodide. Okay, potassium iodide, or rather let's just write Ki. Okay, now Ki simply has the K plus ion, and in both situations of sodium hydroxide and aqueous ammonia, we will get no observations, which means in both cases the colorless solution will remain colorless, which means we will not be able to differentiate between the two, sodium hydroxide and aqueous ammonia. Okay, now let's see, that means 3 is out. Let's see whether we can use 4, zinc chloride. Now zinc chloride will have the zinc 2 plus ion. Okay, and if you remember your QA table, you will remember that for zinc ion Zn2 plus, in both sodium hydroxide and aqueous ammonia, we will get a white precipitate. Okay, and in both cases, the precipitate will dissolve, okay, in excess aqueous sodium hydroxide, and let me write that a bit more clearly, in aqueous sodium hydroxide and aqueous ammonia, which again means since we will be getting exactly the same observation, we will not be able to differentiate between sodium hydroxide and aqueous ammonia if we use zinc. So the only one that will give us different observation in sodium hydroxide and aqueous ammonia is copper 2 sulfate. Therefore, the answer is A, only or one only. Okay, let's go and do question number 8. When a little sodium hydroxide was added to a colorless solution, no precipitate was formed. However, when the solution was heated, a pungent gas was evolved. What was the cation present in the colorless solution, and what was the gas evolved? So, when we are testing with a little sodium hydroxide, we know that we are usually testing for cation. Okay, we get no precipitate with the sodium hydroxide, which means it cannot be zinc, because in zinc we will get a white precipitate. It cannot also be calcium, because we would also get a white precipitate. So we have eliminated A and B. Okay, now therefore the only let's take a look at the second part. However, when the solution was heated, a pungent gas was evolved. Now when you add a certain cation with sodium hydroxide and you heat it, this is basically test for the ammonium ion. And how do you know ammonium ion is present? That is if ammonia gas was evolved, and that is what we got here, a pungent gas, which means we know that it is an ammonium ion, and we know that the pungent gas evolved was ammonia, not nitrogen dioxide. Therefore, the answer is C. Okay. Alright, so now let's take a look at a couple more questions before we end off this video. Number 9. When ammonia solution was added to an unknown solution S, a white precipitate which was soluble in excess aqueous ammonia was formed. Now, again, when we add aqueous ammonia solution or aqueous ammonia or ammonia solution, we are also basically testing for cation. and we get a white precipitate. Now, white precipitate usually means we can have either zinc, aluminum, or lead. Okay, but in this case, okay, let's just write that down. Maybe possibility we get lead 2 plus, we have possibly aluminum 3 plus, and we could possibly have zinc 2 plus. But this time we saw that the precipitate was soluble in excess aqueous ammonia, which eliminates lead, which eliminates aluminum, because in both these cases the precipitate is insoluble in excess. So automatically, in this case, we know that the answer is already zinc. But let us just continue. Sodium hydroxide added. Again, we know that the sodium hydroxide is a test for cation. Okay, we also get a white precipitate, and again soluble in excess, which means this is zinc 2 plus. Okay, so just a note, zinc 2 plus is the only ion where the white precipitate formed with both aqueous sodium hydroxide and aqueous ammonia dissolves in excess. Okay, so zinc 2 plus is the only cation where we get the white precipitate in both sodium hydroxide and aqueous ammonia, and dissolves in excess aqueous ammonia and sodium hydroxide. Okay, so this is a very common one that comes out in exams because it is an easy way to identify the zinc ion. Okay, let us do a last question. Number 10. A sample of colorless solution W containing one cation and one anion. So already we know that it's one cation, one anion, and it is a colorless solution. Now, if it's a colorless solution, generally we can eliminate the colored ions, typically Fe2 plus, Cu2 plus, because usually these are colored. So these are the little clues that you can get along the way. Okay, they was divided into 3 parts. Okay, now here's another thing, a colorless solution, which also means it is a soluble salt. These are the little indications again that you can get, the little clues that you can get from the question. Okay, so a series of tests was done and we get the following observations. To the first portion, add aqueous sodium hydroxide until excess. Now when we see sodium hydroxide added until excess, we know that we are testing for cation. Okay, we get a white precipitate, and the precipitate dissolves in excess sodium hydroxide to give you a colorless solution. So again, white precipitate with sodium hydroxide, we can get lead 2 plus, we can get aluminum 3 plus, and we can get zinc 2 plus. We may even have calcium, but calcium gives you a white precipitate but doesn't dissolve in excess. Second portion, add aqueous ammonia. Again, we are testing for cation, and this time we still get a white precipitate, and again it dissolves. So, which means since zinc is the only one that dissolves in both excess sodium hydroxide and aqueous ammonia, we can eliminate lead and aluminum. Okay, which means A is out, B is out. Third part, add dilute nitric acid followed by barium nitrate solution. Now when we are adding barium nitrate solution, we are testing for the sulfate ion. Okay, and how do we know when a sulfate ion is present? When we get a white precipitate, because we know that we will get a precipitate of barium sulfate. Remember, all sulfates are soluble except calcium, lead, and barium. So barium sulfate is insoluble, which means we have the zinc ion and we have the sulfate ion, which means the answer is D. So I hope that these 10 questions has given you a sample of the thought process required to solve problems involving QA. Okay, so as a quick recap, you have to have a good understanding of what are the tests required for testing for cation, testing for anion, and testing for gases, because these are the usual information that you have to rely on. Also, furthermore, it will be very helpful if you knew your acid reactions as well as your alkali reactions to solve these problems. Okay, so I hope that this video has been useful to you. Again, please feel free to pause and rewind any parts of the video which you find will help you better. Okay, see you. Bye bye.